This lesson focuses on writing equivalent rational expressions. This is going to be important in the next lesson when we start adding and subtracting rational expressions that don't have a common denominator. Now, before we begin on this, it's very important that you studied the lessons. There are 3 lessons that we looked at, and it's very important that you study those lessons. And so one of them was finding the least common multiple. And then in this lesson, we looked at in terms of just numbers. Then the other lesson on least common multiples was on rational expressions, where we had monomial factors and also where we had polynomial factors with more than one term. And then we also talked about finding the least common denominator of 2 or more rational expressions. So you may recall examples like these. All right, so this, like these examples. So these are lessons we've talked about. So it's very important that you review those lessons before studying this. All right, so in this lesson, we're going to write equivalent rational expressions. And so the directions will say something like this. So it'll say, rewrite the rational expression with a given denominator. And so here's what the first example looks like. And I use an example that you all know how to deal with. And so to be able to do this, you need to be able to look at both fractions. So basically, if you look at this, I have 3/8, and I want to write it as an equivalent. And I'm using the word equivalent. So let me write that word, equivalent. Equivalent means equal. Okay, so you want to write this rational expression. So this fraction, let's call this a fraction for right now. And you want to write it so that way you have an equivalent rational expression or equivalent fraction that has that denominator. All right, so remember what we did was we looked at this 32. So I have an 8, and so the question is 8 times what is 32? Well, you would say 4, right? So in your mind, you know that if I'm going to rewrite 3/8 using a denominator of 4, then I need to multiply 8 by 4 to get 32. But remember, what you do to the numerator, you have to do to the, what you do to the denominator, you have to do to the numerator. So basically what's happening is this. I'm multiplying both the numerator and the denominator by 4. Okay, so it's going to look something like that. All right, and so therefore we get 8 times 4 is 32, and then 3 times 4 is 12. So the answer, let me go ahead and write down the answer right here. So the answer, all right, so it says rewrite the rational expression with the given denominator. So the answer will be 12 divided by 32. All right. Now in my math lab, they may just want you to enter the numerator, so you just put 12 in the numerator. So it depends on what it looks like in my math lab as to what you would write. But it did say rewrite a rational expression, so here's my rational expression. Okay, now here's the other thing I want you to remember. So remember talking about the word equivalent. So notice that this fraction is equivalent to this fraction, 12 divided by 32. And remember, see how I'm multiplying both numerator and the denominator by 4? I want you to notice that this fraction is 1. So you got to make sure that whenever you are writing equivalent fractions, that whatever you multiply one fraction by, that whatever you put here in that box, that has to be 1, because 3/8 times 1 is still 3/8. Okay? You just are using different numbers where the numerator and denominator are the same, so that way you can get equivalent fractions with different denominators. All right, so notice that every problem we'll do, it will be 3/8 times a 1, and in that box will be expressions that will give me what I want. Okay, so that's important to remember. All right, so let's look at number 2. Number 2, we have this. So now we're going to start looking at variables. So if you look at your, and these are monomial factors, by the way. So the monomial factors are the easier to deal with sometimes, not always, but sometimes. So if you look at this, I have an x, I want a 4x. So what's missing? What factor is missing? What do I need to multiply this denominator by to get 4x? Okay, that's an easy one. So you notice that what's missing is a 4, right? So what I'm going to do is I'm going to multiply, and remember what we did here. So let me go ahead and rewrite it right here. So negative 3x, okay? And so I need to multiply this by 1, all right? So to make it stay negative 3x. But whatever I put in here, though, in here, I need to multiply x by some factor to get 4x. So what's missing? 4. So if I multiply the denominator by 4, then I have to multiply the numerator by 4. And so therefore, this question mark, which is what you got to write now, this question mark, I'm going to go ahead and say that here. So the question mark will equal negative 3 times 4, which is a negative 12. All right. So the question mark is negative 12. Now in my math lab, they may ask you to put negative 12. All right. On a worksheet that you have to turn in that's not related to my math lab, then you would probably say the answer will be, remember the question mark is negative 12, so you say negative 12 divided by 4x. So negative 12 divided by 4x. So what you found is this. Let me just remind you. So what you found is this. So note, negative 3 divided by x is equivalent to negative 12 divided by 4x. That's what you found. And notice if you reduce this, if you go back to a lesson that you've had before, if you reduce this, remember we multiply by 4, right? So if you divide numerator and denominator by 4, you should get this back. And you do. Negative 12 divided by 4 is negative 3. 4x divided by 4 is x. All right? Okay. So depending on my math lab, this may be what you would write, or this may be what you would write. Okay? All right, number 3, again, we have monomial factors here. So notice, let me go ahead and rewrite this right here. So we have 8 divided by 15y. So I'm going to have to multiply this by some fraction that's equal to 1. So I need that to be a 1. To get a fraction, to get an equivalent fraction with this denominator. So let's think about what's missing. 15 times what is 30? All right, so 2, right? So I need a 2 right here. Y'all agree? Okay. Now, I have a y here. I want a y to the 4th. So y times what is y to the 4th? Well, y cubed. All right, now, what you may want to do also is think about this. So you see how I want this denominator to be 30y to the 4th. I already have a 15y. So 15y times, and then you're trying to figure out what's going to give you this. Well, 15 times 2 is 30. And then y times y cubed is y to the 4th. And so this goes here. You see? So sometimes you may want to do something like that when you're thinking about it to see what goes here. All right, so rewrite this right there, and then figure out what needs to go here to get this, and then that goes there. Okay, but what I do to the denominator, remember I want this to be a 1, so the denominator and the numerator must be the same here. So 2y cubed, and so therefore you just multiply the numerators out. So 8 times 2y cubed is 16y cubed, and then 15y times 2y cubed gives you this. So 30y to the 4th. All right, and so that's your answer. So this would be your answer right here. All right. Now in my math lab, they may ask you for that numerator. So they're going to be asking for this. So we go ahead and put this in red. So they'll be asking for that. And so you would say the question mark would equal, you would, in that box, whatever it would look like in my math lab, you would say 16y cubed. Okay? All right. So writing equivalent fractions, writing equivalent rational expressions. So think about all the different processes you can go through to get what you want. All right, now remember what we just found though. So 8, let me just mention it again. So note, 8 divided by 15y is equivalent to this rational expression. Is equivalent to 16y cubed divided by 30y to the 4th. Okay, that's what you found. All right, now I want you to remember what you did in a previous lesson when you talked about simplifying rational expressions. So if you look at this right here, you see if you divide both numerator and denominator by 2y cubed, so this divided by 2y cubed is 8. Because 16 divided by 2 is 8, y cubed divided by itself is 1. This divided by 2y cubed, 30 divided by 2 is 15, y to the fourth divided by y cubed is y. Okay? So you can always check yourself. So these are easy problems to deal with. You can always check. So number 4, we also have a rational expression. You want to write 2 rational expressions, but we also have monomial factors. So that will be an easy one to deal with as well. So let's think what we have here. So right here, see, I want to rewrite this rational expression to make it equivalent to this one that has this denominator. All right, so if I look at what I want, this is what I have. So I have a y squared. So what do I need to multiply this y squared by to get this? Well, I need a 2, and then y squared times y will give me y cubed. So that's what I need. Okay? So then I'm going to take this right here. So then I'm going to, in my mind, I'm thinking, okay, I have 6y squared. So I've got to multiply by some expression that's equal to 1. So numerator and denominator have to be the same because that's how you can get that 1. So 6y squared times 1 is 6y squared. 6 divided by y squared, excuse me. And then, so I need this to be a 2y, and so I need this to be a 2y. And so therefore that's going to equal 6 times 2y is 12y, and then y squared times 2y is 2y cubed. And so that's the answer you would write. Okay? So that's your answer right here. So 6 divided by y squared is equivalent to this. So note, 6 divided by y squared is equivalent. So 6 divided by y squared is equivalent to 12y divided by 2y cubed. Okay? So that's what we just found. So these two are equivalent to each other. And notice that every rational expression is equivalent to an infinite number of these, to an infinite number of rational expressions. But that one's equivalent to the 1. This is the 1 where my denominator is this. Okay? All right, now, in my math lab, they may ask you for just the numerator. All right, so they may ask you just for the numerator, and so you just put 12y. So in my math lab, if they ask you for the numerator, so notice the question mark here is going to be 12y. Okay? All right, number 5. So again, we're dealing with monomial factors. In a little while, we're going to look at polynomials that have more than one term. So in number 5, you have 11 divided by 3a, and you want to determine what the numerator is, so you can get an equivalent rational expression with this denominator. All right, so if you look at this right here, if you look at this, I have 3a, so 3a times what will give me 9ab squared. So 3 times 3 is 9. I already have an a, and so all I need is a b squared. And always check. So if you multiply these monomials out, you'll get 9ab squared. All right, so what that means is this. So now I got to find the numerator. So what that means is once I find what I got to multiply numerator and denominator by, I'm going to do this. So 11 divided by 3a times 1. All right, and to get that to be 1, the numerator and denominator have to be the same. But I know I've got to multiply 3a by 3b squared to get this. All right, so you see, I'm multiplying 11 divided by 3 to get an equivalent rational expression with that denominator. And so I got to do the same thing to the numerator. And so therefore my answer will be 11 times 3b squared is 33b squared. 3a times 3b squared is 9ab squared. Okay? And so what you just found is this. So you found that 11 divided by 3a. So note, 11 divided by 3a is equivalent to a rational expression with this denominator, 9ab squared, where the numerator is 33b squared. Okay? All right. And you can always check, because remember how we got this. We got this by multiplying multiplying numerator and denominator by 3b squared. So if I simplify this, I'll get this back. So to simplify, I would need to divide 3b squared, both numerator and denominator. And so when you do that, you do get this back, because 33 divided by 3 is 11. B squared divided by b squared is 1, so you get 11 here. And then 9ab squared divided by 3b squared gives you this back. All right, so that's number 5. Okay, let's look at number 6. So number 6, we have this rational expression. Okay, and so again, I have 3r as my denominator. I want to write an equivalent rational expression with 12r to the 5th as my denominator. So let's think about what we need to have here. So I have 3r, I have a factor of 3r, so 3r times what factors will give me this? So 3 times 4 is 12, r times r to the 4th is r to the 5th. So that's what I'm going to use. So in my mind, I know that I have 5t squared divided by 3r, and I got to multiply this by some fraction that's equal to 1 to get a denominator that is 12r to the 5th. Okay? So 3r times 4r to the 4th will give me 12r to the 5th. You can see that. But what I do to the denominator, I must do to the numerator. So I got to multiply the numerator also by 4r to the 4th. And so therefore you multiply the numerators out. So 5 times 4 is 20. T squared times r to the 4th is t squared r to the 4th. And so that would be your equivalent rational expression. So depending on how they want the answer written, you could say the answer is 20 t to the 4th r to the squared r to the 4th divided by 12r to the 5th. Or my math line may just ask you to write the numerator, and the numerator, see that blank here? So they'll probably have a little question mark here. And so the numerator would be 20 t squared r to the 4th. All right. Now I want you to note something though before we go on to the next one. Note, what I found is that 5t squared divided by 3r is equivalent to this right here. So to 20 t squared r to the 4th divided by 12r to the 5th. Okay, that's what you just found. Okay, number 7, you have these two rational expressions. So you have this rational expression, and you want to write an equivalent rational expression that has this denominator. Now notice the difference between the previous 6 and this one is that in the previous 6, the denominators were monomial factors. Now these are not monomial factors. So you gotta remember you got a factor now. So x plus 7 I can't factor any further, but 3x plus 21 you can. So you want to rewrite this. This is 3 times x plus 7. So when you factor out the 3. So notice I want to go from here to here. So I already have the factor x plus 7, right? So it's missing. I'm missing a 3. All right, so what that means then is this. So I'm going to go just kind of like we did here. So I'm going to rewrite this. So y divided by x plus 7, okay? I'm going to multiply this by some fraction that's equivalent to 1, so I can get an equivalent rational expression with this denominator, 3 times x plus 7. Now always go ahead and leave it in factored form, because when the next lesson, when you add and subtract, you want to keep the denominators factored. And you're going to see that in the next lesson when you add and subtract rational expressions with different denominators. And so the question is, what do I need to multiply x plus 7 by to get this? Well, I need to multiply by the 3. So what I do to the denominator, I do to the numerator. Notice that 3 divided by 3 is still 1. And so therefore we multiply the numerators out. And so y times 3 is 3y. And then my denominator I already did. That's this right here. All right, so your answer will be 3y divided by 3 times x plus 7. Okay, and you, again, leave the denominator factored. That's going to be important in the next lesson. Now, you could also, remember, where in the original problem this numerator was blank. So you found what the numerator is, so you can say the numerator, and if this is my math lab, we'll probably ask you for the numerator only, and you get 3y. All right. Okay, so again, note what we just found. So what we just found is that, based on this as well, that discussion, is that y divided by x plus 7 is equivalent to 3y divided by 3 times x plus 7. That's what we found. Okay. All right, number 8. Number 8 again. Now notice that on the so you have this rational expression, and you want to write a rational expression that's equivalent to one that has this denominator. So this denominator is already factored. This is not, though. All right, so you got to factor your denominators in both cases, the left one and the right one. All right, so in the left one, you have 5 times x plus 6. Okay, so the question is this. So if you think about it, if you go ahead and rewrite it just like we did here, I have 3 divided by, and leave it in factored form, 5 times x plus 6. That's important, especially in the next lesson. Okay, so that'll be important in the next lesson. Leave the denominator in factored form. And you want to multiply this by some rational expression that's equal to 1. Okay, so 3 divided by 5 times x plus 6 times 1 is still 3 divided by 5 times x plus 6. Okay, you're just going to rewrite it in a rational expression that looks different than this, but it's still equal to itself because this is 1. So when I look at what I want, so remember this is what I want, right? Okay, so I have the 5, I have the x plus 6, what's missing? So what do I need to multiply this by? What do I need to multiply this by to get this? So what factor is missing? A. So A is missing. So I'll write an A here and A here, because A divided by A is 1. Remember, to keep these rational expressions equivalent, this product has to be a 1. So what I do to the denominator, I do to the numerator. It's the only way I can get that to be a 1. So therefore, my numerator is just 3 times A. And so you're done. So note, what you just found is that 3 divided by 5 times x plus 6 is equivalent to 3a divided by 5a times x plus 6. Those two are equal to each other. So if you simplify this, okay, what that means is that if you simplify this, you're going to get this back. And notice, if you see how I got this, I multiplied by a, both numerator and denominator. So if I divide 3a by a, I get 3. If I divide this product by a, I get 5 times a plus 6, which is what this is. Okay? All right, number 9. So number 9, you have these two rational expressions. So you want to write this rational expression to have this denominator. Okay, so that's what you're interested in. So again, though, notice that those are polynomials with more than one term. Sometimes I'll say those are multi-term polynomials. Multi-term. So here I can factor out a 4. So let's go ahead and do that. So I get 4 times t minus 5. And then here I can factor out an 8, right? So I get 8 times t minus, I'm sorry, that's 5. T minus 3. All agree? Okay. Now, so let's look at what's missing here. So this is going to be a little bit more challenging than number 8, but that's okay. We can handle that. So I need to multiply this rational expression by some product to get this, to get an equivalent rational expression with its denominator. So let's think about this. I have 3t divided by 4 times t minus 5, okay, times, and I got to multiply this by some fraction, some rational expression to get, see, I don't know how much room I'm going to need here, so I'm going to leave this little space open, to get some rational expression with this denominator. And always leave it in factored form, so 8 times t minus 3. So if you look at this, okay, so actually I messed this up, I'm sorry. So this should have been a, let's see how I have this to be a 20, and so this is 4 times t minus 5. I need this to be a 5. So let's make that 40. Sorry about that. Let's make that 40. And so this is going to be, so when you factor out a 40, this right here is 40. So 8t minus 40. That's 8t minus 40. So I get 8 times t minus 5. So I need this to be this, right? Okay. So what's missing here? So what's missing is 4 times 2 is 8. So that's what's missing. So I got to multiply both numerator and denominator by 2. And so 3t times 2 is 6t. All right, so that'll be your answer there. So remember, that's a 1 right here. And so there, I want you to note that 3t divided by 4t minus 20. All right, or you can write it in factored form. Doesn't matter. Does not matter. But I would write it in factored form. So I would say 3t divided by 4 times t minus 5. Because in the next, when you add and subtract, writing in factored form will be important. Is going to equal 6t divided by 8 times t minus 5. Okay, so that's what you found. So in terms of the answer, depending on how you're asked, so if they just want the equivalent rational expression, then you would say this, 6t divided by 8 times t minus 5. My math lab, they may want to know, well, what is this numerator only? So the numerator would have to be 6t. All right, so I did write the problem wrong, so this should have been 8t minus 40. That's the only way I could have gotten this to look like this by multiplying by 2. Okay, number 10. Let's look at number 10. So number 10, you have this rational expression, and you want to write it into this equivalent form. Okay, so if I look at this, I can factor out a z, right? So I get z times z minus 3. So the first thing you have to do is factor the denominators. This is already factored form. You'll see that? Okay. So the question is, what do I need to multiply this by to get this? So I already have a factor of z. I already have a factor of z minus 3. So what's missing here? What do I need to multiply this by to get that? So I got to multiply this by this. Okay, so in your mind, you have this. In your mind, you have 16 divided by z times z minus 3 times some rational expression, and I want to get a rational expression, an equivalent rational expression that has this denominator. That's what you're asking. That's what you want to know. Okay, so notice I already have this part. So what do I need here to get all of this? Well, I need a z plus 4. So I'm going to multiply the denominator by z plus 4 and the numerator by z plus 4. And so therefore my numerator, I get 16 times z, that's a z here, plus 4. Okay? And so you can leave your answer as this. So the answer, so remember you now wrote an equivalent rational expression for this. So this is equivalent to this that you just found. So the answer is 16 times z plus 4 divided by, and leave the denominator in factored form, z times z minus 3 times z plus 4. Now let me just say this, or you can write it like this. In the next lesson, when you're going to add and subtract two rational expressions, you're going to leave the denominators factored, but you're going to see, and you're going to see this, you're going to see why when we get to there, but you're going to multiply the numerator out. So for right now, though, you can leave your answer like this, or you can distribute. So if I distribute, I get 16z plus, and then 16 times 4 will be, let's see, that's what, 64, okay? Divided by z times z minus 3 times z plus 4. But leave the denominator factored. Now, there's a reason why in the next lesson, you're going to really end up, when you add and subtract, you're going to end up writing this as this. You're going to see that later on. Okay, but for right now, either of these are fine. Now, remember, in the original problem, this was the original problem, so you'd probably see a little question mark here. So you can say also the question mark will be either this or either one of these numerators. Does not matter. So 16 times z plus 4 or 16z plus 64 if you distribute. Okay? All right, let's look at number 11. So number 11, you have this rational expression. You want to find an equivalent rational expression that has this denominator. So notice it's already in factored form, so that's good right here, but this is not. So we got to factor out, in this case, a 6. So if I factor out a 6, I get 6 times a plus 7. So look at this and look at this and what's missing. So what do I need to multiply this denominator by to get these factors? So notice I already have the 6, right? And I already have the a plus 7. So what's missing here? What is it you don't see here that you see here? Well, you don't see the x. So what you're saying then is this. So you're going to say, all right, so using this idea, so you're going to say, I have 5a plus 3 divided by 6 times a plus 7. Notice factored form. I got to multiply this by some rational expression that's equal to 1, because 5a plus 3 divided by 6 times a plus 7 times 1 is still this. But I want to get a denominator that looks like this instead. So I want to get an equivalent rational expression. So these two rational expressions are equivalent. They're equivalent because this is a 1 right here. Okay? So this times this is this, and you're saying that's equal to this as well. As long as this is a 1. And so what is it that I'm missing here that I need to get here? I'm missing the x. So I'm going to multiply both numerator and the denominator by x. Okay? And so therefore I have this binomial times this monomial. So I'm going to write this as x times 5a plus 3. All right? And so that's my numerator. So that's what I'm looking for here. So the question mark would be this numerator. X times 5a plus 3. Or you can distribute. So if I distribute, you would have 5ax plus 3x. Okay? Now, I want you to note what you just found, though. What you just found is this. So note, you found two equivalent rational expressions. 5a plus 3 divided by 6 times a plus 7 is equivalent to x times 5a plus 3 divided by 6x times a plus 7. Now remember, in the next lessons, it'll be important that you leave the denominator factored, but you're also going to see that when you write equivalent rational expressions in the nex lesson, that if you get this, you're probably going to want to distribute. So you can go ahead and distribute. So you can write it as 5ax plus 3x divided by 6x times a plus 7. All right. Number 12. So in number 12, we have this. So notice you want to write an equivalent rational expression that has these denominators. It has these factors. So this is already factored. It's already in factor form. This is not. So let's go ahead and factor this. So this will be r minus, let's see, what's that? I think I need to rewrite this. Let me just double check. Okay, so no, I'm good. So that's going to be r minus 5 times r plus 2. I'm going to double check. Yep. All right, so this is what I have. This is what I want. So what factor you see that's missing here? So you see you have the r minus 5, right? So in your mind, you know, and then think about this. So in your mind, you know you have this one already. You have this one, and you have this one here, right? So you're missing this one. All right, so what you're saying then is this. You're saying 16r divided by, and leave this in factored form, r minus 5 times r plus 2 times some rational expression where the numerator and the denominator are the same, so you can get this to be times 1, will give you an equivalent rational expression that has these three denominators, these three factors, r minus 5, r plus 2, times r minus 3. So I got to multiply this by r minus 3 to get this. But what I do to the denominator, remember, we got to keep it a 1, so you got to have the numerator the same as well. And so therefore, you're almost done. So the numerator then, this numerator, will have to be this times this. So you get 16r times r minus 3. Okay? And so there are multiple ways of writing the answer. So the answer, if depending on the directions, you could say this is the answer. This right here is equivalent to this. So this is equivalent to this. So that's what you found. So these two are equivalent. Okay? Those are equivalent. E-Q-U-I-A-L-E-N-T. Those are equivalent. So the answer would be this. So you'd say 16r times r minus 3 divided by r minus 5 times r plus 2 times r minus 3. And again, don't multiply the denominators out. Leave it in factored form. I would not even want to try this. This is three binomials we're multiplying together. But in the next lesson, depending on where you are in the process when adding and subtracting, you may need to multiply the numerators out. So let's go ahead and do that. So 16r times r is 16r squared, and then 16r times a negative 3 is a negative 48r. Okay, and then leave the denominators factored. So r minus 5 times r plus 2 times r minus 3. So either one of those would be your answers. Now, if they just want what the numerator needs to be, then you would just say 16r times r minus 3, depending on what they want the numerator to be. And then you could distribute as well. So 16r times r is 16r squared. And then 16r times a negative 3 is a negative 48r. Okay? All right, number 13. So in 13, we have this. All right? And so don't let that throw you off. So you may say, so remember, you got to factor. If you look at this, though, this cannot be factored. All right, so look at that. There's no way you can factor this. But this right here, that's the difference of two cubes. And so you have to remember how to factor the difference of two cubes. So I have z cubed minus 64. And so I know this is a difference of two cubes because I can fill in these parentheses. So z times itself 3 times is z cubed, and then 4 times itself 3 times is 64. And so therefore, remember, when factoring the difference of two cubes, it's a binomial times a trinomial. And that binomial is just this part here, z minus 4. The trinomial is where you take the expression that's in the first parentheses and you square it, and then plus, because that's always the opposite of this sign, the product of what's inside the parentheses, so z times 4 is 4z, plus, and then the last squared. So 4 squared is 16. All right, so that's what this is. So I want you to notice this right here. That's going to be x minus 4 times x squared plus 4x plus 16. Notice that this is this, right? So no, and remember when you factor difference of two squares, or difference of two cubes, or the sum of two cubes into a binomial times a trinomial, as long as this GCF is 1, then this trinomial cannot be factored. All right, so just keep that in mind. So basically what the numerator will be then is this. So you know you have this right here. So that's 3x minus 2 divided by x squared plus 4x plus 16. And so you want to write an equivalent rational expression that has this denominator instead. So you're going to multiply this by some rational expression to get, and I should have put this a little bit lower, but to get this denominator. So x minus 4 times x squared plus 4x plus 16. So what is I got to multiply this by? Well, I got to multiply, remember this needs to be a 1 right here. So what is I got to multiply this denominator by to get this? What's missing? X minus 4. But what I do to the denominator, I do to the numerator. So my numerator is just these two binomials multiplied together. So in other words, it's just 3x minus 2 times x minus 4. And you can leave your answer like this. All right, so the answer, remember, these two are now equivalent, so those are equivalent rational expressions, so this will be your answer. So this is equivalent to this. So you're going to get your answer being 3x minus 2 times x minus 4 divided by x minus 4 times x squared plus 4x plus 16. Okay? Now, at some point in the next lesson, you may need to multiply the numerators out, but always leave the denominator in factored form. So notice if I use the FOIL method here, 3x times x is 3x squared. The outer is a negative 12x. The inner is a negative 2x. So I get negative 14x. And the negative 2 times negative 4 is a positive 8. All right, over the denominator. Leave the denominator factored form. So the reason why I fall this out, because you're going to see in the next lesson we add and subtract, depending on where you are in the process, you may need to multiply this out. All right, so I wrote in both forms. So either one of those is fine. Okay. All right, number 14, we have this. And so notice this part's already factored, right? And so let's go ahead and factor this. So here I can factor out an x. And so I get x squared plus 12x plus 35. Then let's go ahead and factor this further. So I get x times, let's see what we get here. So it'll be x plus 7 times x plus 5. Yep, that's right. And so now look at what you have and what you want. So I want to write an equivalent rational expression that has had this denominator, and now I want it to look like this. So I have 3 factors here. Here I have 4. So which one's missing? I have the x. I have the x plus 7. So if you want to kind of do like what I'm about to do, so you have the x right here. You have the x plus 7. You have the x plus 5. So that what's missing is this one. So what you're saying in your mind is this now. You're saying, okay, so I have x divided by x times x plus 7 times x plus 5 times some rational expression that's equal to 1. And I want to get an equivalent rational expression. I want to get an equivalent rational expression that has this denominator, x times x plus 5 times x minus 2 times x plus 7. And so I got to multiply these 3 factors by, what was it, x minus 2? By x minus 2 to get this. But what I do to the denominator, I do to the numerator, so I can keep this to be a 1. And so, therefore, I get x times x minus 2. And so this right here is your answer. So you wrote an equivalent rational expression. So I don't have enough room here, so I'm going to write small. So note, you just found that x divided by x times x plus 7 times x plus 5 is equivalent to this, x times x minus 2 times x plus 5 times x minus 2 times x plus 7. So that's what you found. Now, remember, you can distribute, or you can distribute. So x times x is x squared, x times a negative 2 is a negative 2x. But leave the denominator in factored form. That's going to be important again. And I would not want to multiply these 4 factors out anyway. All right, so that's your answer. Okay, so see the directions. Remember, the direction says rewrite the rational expression with a given denominator. All right, so you rewrote this rational expression right here with this denominator, and this is it, or this denominator, either one of those. So either one of those would be your answer. All right. Number 15. Okay, 15. So notice in 15 you have this rational expression, and you want to write an equivalent rational expression that has this denominator. So you got to figure out what that numerator is. In every case, you have to figure out that numerator. So what should the numerator be? So if you go back to let's say 13, okay, so you had to find out what that is to get these two to be equivalent. Well, the numerator was this. So either this right here or this. So question mark would have been either 3x minus 2 times x minus 4, or when you fold it out, you got 3x squared minus 14x plus 8. Now in 15, notice that I have this rational expression. I want to get an equivalent rational expression that has this denominator. So I got to figure out what that numerator needs to be. Okay, so this denominator is already in factored form, so I got to factor the denominator here. So this one's, I can factor out an x. I get x squared, x times x squared minus 9x plus 20. And so if I factor this further, I get x times x, let's see, minus 5 times x minus 4. Okay, And so notice I have the x, right? I have the x minus 4. I'm missing the x minus 5. So what I need to do is this then. To find the equivalent rational expression, I'm going to take what I had originally, 6 times x plus 5, divided by x times x minus 4. I have to multiply this by some rational expression, that's equal to 1, to get an equivalent rational expression with this denominator, x times x minus 5 times x minus 4. So I got to figure out what that numerator needs to be here. So to get that, though, I know that I need to multiply these two factors by x minus 5. But what I do to the denominator, since I'm multiplying the denominator by this, I got to do the same thing to the numerator. So what I have then is this. I have 6 times x plus 5 times x minus 5 now. All right? And so that would be your answer here. So you found that this is equivalent to this. So the answer would be 6 times x plus 5 times x minus 5 divided by x times x minus 5 times x minus 4. All right. Now, again, let me show you how to deal with the numerator here. So this could be your answer, or you can multiply the numerator out, because depending on the process you are in the next lesson, you may need to do that. So let me just kind of remind you how to do this. So I have 6 times x plus 5 times x minus 5, right? Right here. Okay, so remember, you're multiplying three factors here. Remember, multiplication is commutative. The order in which you multiply does not matter. So if you look at this, you notice that this is the difference of two squares, or the factored form is the difference of two squares. So if you follow this out, and notice that 6 times, you're going to get x squared. The outer and the inner cancel out, and you have minus 25. And then distribute, you get 6x squared minus, and that's going to be 150. Okay? Now you could have also, I just want you to see this, you could have also done this. You could distribute the 6 only in here. You can't do it in both. Okay? 6 times this only. So that's 6x plus 30. And then multiply by x minus 5. And then if you FOIL, I want you to notice something. 6 times x is 6x squared. The outer is a negative 30x. The inner is a positive 30x. And then a positive 30 times a negative 5 is a negative 150. And so notice these add up to be 0. And so you get 6x squared minus 150, which is what this was. Okay? So basically the numerator then you can also write as 6x squared minus 150. But leave the denominator factor. That's going to be important in our discussion in the next lesson. Leave the denominator factor. Okay, let's look at a couple more. But I think you should get the handle on how to write equivalent rational expressions. Okay, don't let this one throw you off. This looks pretty messy, but it's not. So if you try factoring this, you'll notice that you won't be able to factor this at all. Okay, but let's go ahead and look at what we have here. So notice the GCF, they're factors of x in all of these, and then the factors of y in all these terms. So if you look at this, I can factor out. So the GCF would be, let's look at the x's first. There are 6 factors of x here, 5 here, 4 here. So remember, in finding the GCF, when you're factoring out the GCF, you got to take out the one with the smallest number of exponents. So I need to factor out the x to the 4th. For the y's, that's y to the 1st, y to the 2nd, y to the 3rd, so I'm going to factor out a y. So then I get 9. 9 times x to the 4th times x squared is x to the 6th. I already factored out the y, so I don't need any y's here. Plus x to the 4th times x is times y. X to the 4th times x is x to the 5th. Y times y is y squared. Minus x to the 4th, that's all of these. Y times y squared is y cubed. I want you to notice that this is this. So that's going to make things a little bit easier for us in this one. So again, I want to write an equivalent rational expression that has this denominator. So I got to figure out what that numerator is. So I have x plus 3y divided by 9x squared plus xy minus y squared times some rational expression that's equal to 1. and I want to get a new rational expression, an equivalent rational expression that has this denominator. Okay, so that's the goal. And so when I do that, I know that I got to multiply this by this to get this. So x to the fourth y. But what I do to the denominator, I got to do to the numerator. So when you multiply fractions by a number, the numerator and denominator must be the same product. And so therefore I get this binomial times this monomial. So I get x to the fourth y times x plus 3y. All right, and so that would be your equivalent rational expression, that right there. So the answer would be this. X to the fourth y times x plus 3y divided by x to the fourth y times 9x squared plus xy minus y squared. Okay? Now, if you want to distribute, you can. You can distribute the numerator. Don't distribute the denominator. Leave the denominator in factored form. So the numerator, you could say x to the fourth y times x is x to the fifth y. X to the fourth y times 3y would be 3 x to the fourth y squared divided by the denominator, which is x to the fourth y times 9x squared plus xy minus y squared. All right, and then finally, remember you found the numerator needs to be. The numerator is this right here. That's your numerator. Okay. And then finally this one. So notice that in 17, if you try factoring the denominator, you can't. But remember what you're trying to do. You're trying to write an equivalent rational expression that has this denominator. This is what you have. This is what you want to get to. Notice that that's the difference of 2 cubes. So when I factor this, that's going to be x minus y times x squared plus xy plus y squared, which is this. So that's kind of like what we just did, isn't it? So we have 6x minus y divided by this. And so my goal is to figure out what do I need to multiply both the numerator and the denominator by to get an equivalent rational expression that has this denominator. So I want this denominator. Okay? So notice this I already have, so what's missing is this one. So I got to multiply both numerator and denominator by x minus y. And so now what I have is this binomial times this binomial will be the new numerator. And then this times this is this. Okay, so you found your answer. So this rational expression is equivalent to this one. That's what we found. So those two are equivalent to each other. And so your answer, you could say this, 6x minus y times x minus y divided by x minus y times x squared plus xy plus y squared. And notice if I simplify based on a lesson we learned a while back, the x minus y's divide out, and you get this back. See this right here? You get this. Okay? All right. Now, depending on my math lab, they may ask you for the numerator only. What does this numerator need to be for those two to be equivalent? Well, it would just be this right here. So you would say question mark would equal 6x minus y times x minus y. Now, if you want to FOIL this out, you can. So let's go ahead and FOIL that out. So when you FOIL that out, let's say you get 6x minus y times x minus y. And so 6x times x is 6x squared. The outer, that's a y. The outer is negative 6xy. The inner is a negative xy. And the last, a negative y times a negative y is a positive y squared. Combining like terms, I get 6x squared. That's going to be a negative 7xy plus y squared. So that'll be the numerator. So you can say either this or this. But again, always leave the denominator in factored form. 6x squared minus 7xy plus y squared. Or in this case, it would be 6x squared minus 7xy plus y squared divided by the denominator. Okay, so that should help you to understand how to write equivalent rational expressions. All right, so at some point, probably in a couple of lessons, we're going to start adding and subtracting. So all this can be important. So it's very important to understand how to rewrite rational expressions with a given denominator. So how to rewrite equivalent rational expressions. Okay, so that's going to take care of this lesson.